This micro-credential addresses compression concepts in small engines and consists of 4 targeted skills. This targeted skill provides information about compression basics. There are 4 strokes of an engine that make up a full cycle. The engine must go through each of these 4 phases in an exact order so that it will start and continue to run. The first phase is the intake stroke. The piston goes down quickly, creating a vacuum in the cylinder. The intake valve is opened mechanically and a fresh air and fuel mixture rushes into the cylinder. The second phase is the compression stroke. The intake valve closes, trapping the mixture in the cylinder. The piston travels upward, squeezing the mixture into a tiny space. The third phase is the power stroke. The spark jumps across the electrodes of the spark plug and ignites the air and fuel mixture. The resulting explosion pushes the piston down. The fourth phase is the exhaust stroke. The exhaust valve opens mechanically while the piston moves upward. The squeezing action of the piston pushes the now burned mixture out of the cylinder past the exhaust valve. The compression stroke and exhaust stroke are very similar. The piston pushes on the mixtures to make them move. During compression, both valves are closed to purposely trap the air-fuel mixture in the cylinder. However, during the exhaust stroke, the exhaust valve opens to give the burned mixture a route to leave the cylinder. If the piston doesn't compress the air and fuel mixture, it will still burn inside the cylinder, but it won't burn with enough force to move the piston. The engine needs a strong explosion to push the piston and other parts attached to it. For example, in a flintlock rifle, gunpowder is placed into the barrel first. A paper or small leather patch goes into the barrel, followed by the ball. A ramrod is used to pack it all together to compress it. Ignite the powder inside the barrel and that burning creates pressure. Pressure builds and grows until something must give. The barrel is not going to burst, but the patch and ball will yield the force of the explosion and will send the ball flying several hundred yards. Using the same rifle with the same amount of gunpowder inside the barrel with a new patch and ball, but not compacting them with a ramrod, no compression will occur. When the gunpowder ignites inside the barrel, it will burn, but it has too much space to burn. No pressure will build, and the ball may not leave the barrel at all. A firecracker is another good example. A firecracker has gunpowder inside with several layers of paper wrapped around it. The fuse is stuck down through the paper wadding to ignite the powder. Ignite the fuse and that ignites the gunpowder. The pressure builds on the inside, finally overcoming the paper, resulting in a loud bang. Take a firecracker apart. Sprinkle the powder on a surface and do not use the paper. Lay the fuse alongside the powder and ignite the fuse. The powder will burn, but it will not make a loud bang. Why? No compression. Once again, an explosion is required, not just a flash. The idea of compression is key. An engine needs a minimum of compression pressure to start and run. Low pressure might be enough to start the engine, but it will not be enough to provide strong power. Low pressure will keep the engine from starting. High compression pressure is not desirable either. Too much pressure will make it difficult for manual or electric starters to spin the engine. Many engines with high compression ratios have a built-in compression release mechanism. A small amount of compression is vented to cause the engine to spin freely. Once started, the release is disengaged, and appropriate compression is restored for strong power output. Since good compression is key, that is the first area to troubleshoot when an engine won't start. Investigate the many reasons why compression pressures are low or non-existent. If no compression issues are found, then it's time to move on to troubleshooting spark concerns. Then fuel problems. Finally, remember the importance of the compression portion of the cycle. Without good compression, the engine will simply not run.